I want you to close your eyes for a second.
Okay.
Seriously, humor me here. I want you to transport yourself back to the year 2008.
Oh, wow. Going back a bit.
Yeah, you are sitting in a movie theater. The floor is, probably sticky. The popcorn is definitely stale. The lights go down, and Robert Downey Jr. steps onto the screen.
A pretty seminal moment in cinema history, I mean, if we're being honest.
Absolutely.
Cool.
But he is not just a guy in a metal suit. He is Tony Stark. And sure, the flying suit was cool. The repulsor beams were flashy. Blowing up a tank with a tiny wrist missile. Awesome.
Right.
But be honest with me. What was the actual dream? What was the thing that made you sit there and go, I want that life?
It wasn't the suit.
Exactly.
It was the house.
It was absolutely the house. That massive Malibu cliffside mansion, the transparent glass panels that just seemed to know exactly what he needed before he even asked for it.
The holographic displays floating in the air.
Yes. And most importantly, JARVIS. That seamless, incredibly witty, invisible intelligence that controlled literally everything. It didn't feel like a computer.
No, it felt like a butler. A butler who just happened to be a ghost living in the machine.
Right. It was the promise of a home that wasn't just a container for your stuff. It was an active participant in your life.
A living machine, if you will.
Exactly. JARVIS wasn't an app you had to open. He was the atmosphere you lived inside of.
And then, we all left the theater. We grew up. And Silicon Valley came along and told us, hey, good news. The future is finally here.
Right.
We all went out and bought smart speakers thinking we were getting JARVIS.
And what did we actually get?
I'm sorry, I'm having trouble connecting to the internet right now.
Oh, man. Every
Okay.
single time. Or the absolute classic scenario. You are in the kitchen. Your hands are completely covered in raw chicken marinade. You shout at a plastic puck on the counter. Set a timer for 20 minutes.
And it replies, okay, playing 20 minutes by Lil Uzi Vert on Spotify.
It is tragic.
It really is.
It is not elegant at all. It is mostly just us shouting at cheap plastic. It is what I call the dumb smart home reality.
Yeah, we totally traded the dream of intelligent automation for the reality of voice-activated remote controls. Remote controls that desperately need a Wi-Fi connection and have the listening comprehension of, like, a distracted toddler. Well, it is actually worse than that when you think about it. We created a massive system of dependency.
How do you mean?
We build homes that fundamentally break when the internet goes out. If AWS has a minor hiccup in a server farm in Virginia, you literally cannot turn on your living room lights in London.
Which is insane.
It's the exact opposite of the Tony Stark dream.
But, and here is where our deep dive today gets really, really interesting. Someone out there decided that the Tony Stark dream shouldn't just be a movie prop anymore.
We have a massive stack of source material to go through today.
We do. Research papers, commercial pitch decks, extensive GitHub repositories, and it all centers around one specific engineer.
Kiran Achari.
Yes, and that is pronounced Achari.
Kiran is a deeply fascinating character. He is an engineer with a very serious background in bone system engineering.
Which is rigorous stuff.
Very rigorous.
Yeah.
And he basically looked at the current state of the smart home industry, the Alexas, the Googles, the Cirrus, and he just said, this is garbage. I can do better.
And the crazy thing is, he didn't just want to buy a better system. He decided to build one entirely from scratch.
Starting right in his own house.
Right, a private residence referred to in the documents as Ayanthiyara Chitrakoot. And from that personal project, it evolved into a full-blown luxury brand called Vœrynth Système.
Vœrynth. I mean, even the name sounds like something pulled straight out of a high-concept sci-fi novel.
What does it mean?
It stands for the voice of the labyrinth, roughly speaking.
It just sounds expensive.
Oh, it is remarkably expensive.
Okay.
But the core philosophy behind it is what we are really dissecting today. This is an entire ecosystem that actively hates the cloud.
Hates the cloud.
It treats privacy as the ultimate luxury good, and it is powerful enough to run a multi-million-dollar superyacht or a massive sprawling estate without sending a single packet of data back to Silicon Valley.
So our mission today is to unpack all of this. We are talking about bilingual AI assistants that actually understand cultural nuances.
Super yachts that wake you up gently when the anchor starts to drift in the middle of the night.
And a website that literally loads pages before you even click on them. This is what happens when a hardcore engineer decides to fix the smart home by making it, well, actually smart.
And perhaps, most importantly, we are going to explore why the richest people in the world are suddenly utterly terrified of the cloud.
Oh, we are definitely going to spend some time on the rich person paranoia aspect. It turns out billionaires really do not want big tech companies listening to their private dinner conversations. Who knew?
Shocking revelation, I know.
Yeah. But let us start right at the beginning, the origin story. Because before this was a highly commissioned luxury brand called Vœrynth. It was literally just an engineer in his house trying to solve a very specific, very frustrating problem.
Right. We have this foundational document here. It's a technical case study titled Amu and Mycroft at Home.
Which reads almost like a diary.
It basically is Kiran Achari's engineering diary of building the very first prototype. And he identifies a glaring problem that Amazon and Google have largely just ignored for a decade.
The bilingual problem.
Exactly, the bilingual problem.
This resonated with me so heavily. I have friends who live in bilingual households, and their smart speakers are basically just expensive paperweights.
Completely useless. The technical linguistic term for this is code switching.
Break that down for us.
Code switching is a phenomenon where a speaker naturally alternates between two or more languages, or even language varieties, in the context of a single continuous conversation.
Give us a concrete example of what that actually looks like in practice.
So in Kiran's case, the household speaks both Malayalam and English. A typical sentence spoken in that house isn't neatly just one language or the other.
Right, is blended.
Yes.
Yeah.
You might want to say, turn off the smart plug in the hall. But the grammar structure being used is Malayalam, the noun is English, and the syntax is a total mix.
So you would say something like, wait, let me look at the phonetic spelling here. Hall aisle smart plug off cheyu.
Perfect. Hall aisle means in the hall.
Okay.
Off cheyu means do off or turn off.
Got it.
To a human being who speaks what they sometimes call Manglish, Malayalam, and English mixed, that sentence is perfectly clear. Crystal clear.
But to a standard off-the-shelf voice assistant.
That is absolute total gibberish.
Because they are strictly monolingual.
They are rigidly monolingual by design. They hear Hall aisle and their algorithms scramble to match it to an English phone.
So they might think you said Haley or Holy.
Exactly. They try to match it to a random song title on Spotify or a contact name in your phone book. The system simply does not understand that you have just switched grammatical frameworks mid-sentence.
I can completely see the frustration there. You are literally just trying to turn off a desk lamp, and the machine starts calling your Aunt Haley in the middle of the night.
And the worst part is, you cannot just teach Alexa to fix this.
Why not?
Because the massive cloud models these companies use are trained on distinct, isolated data sets. English is kept in the English box. Malayalam is kept in the Malayalam box.
The data sets don't cross over?
No. The code-switching data set, the way millions of people actually talk in real multicultural homes, is relatively small and incredibly hard for big tech to effectively monetize. So they just ignore it.
So Kiran looks at this and decides, I am not going to wait around for Google to fix this for me. He builds a dual assistant system.
Two entirely different personalities, two distinct brains.
Tell us about Amu and Mycroft.
This is where we get into what the papers call the persona architecture, and it is honestly brilliant.
How does it work?
He realized that different tasks in a domestic environment require different vibes or different modes of operation. So instead of having one slightly schizophrenic AI trying to be everything to everyone, he split the system in two. First, you have Amu.
Amu.
Yes, Amu is the Malayalam first persona. She's specifically designed to be warm, highly energetic, and she uses the column dialect.
I absolutely love that he programmed a specific regional dialect into the AI. That is such an incredible specific detail. Why go to that level of depth?
It is absolutely crucial for creating that authentic at-home feeling. The column dialect has a very specific cadence, a recognizable warmth to it.
It makes it feel human.
Exactly. Amu handles the daily domestic routine. She manages the ambient lighting, the grocery lists, the daily family check-ins.
Like a digital caretaker.
She is essentially the host mom of the entire AI system. She asks if you have eaten lunch yet. She reminds you to take your umbrella because it looks like rain.
And then on the other side of the spectrum, there's Mycroft.
Mycroft is the systems butler.
That name is great.
He is English first, and he is heavily based on JARVIS, or Alfred from Batman.
So very proper.
Very proper. His personality is explicitly programmed to be pragmatic, dry, and highly professional. He handles all the complex technical tasks, the strict security protocols, the heavy lifting of the network.
So you have this fascinating dynamic where you might ask Amu, hey, what should we make for dinner tonight? And she replies in warm Malayalam with a suggestion about a specific curry.
Right.
But if you suddenly say, "System, give me a report on server integrity," Mycroft steps in.
Exactly. Mycroft cuts in with a very crisp, dry British accent saying, server load is currently at 15%, thermal status is nominal.
They don't step on each other's toes.
They do not compete at all. They actively collaborate. It creates a household dynamic that feels populated rather than just a sterile technological interface.
But wait, mechanically speaking, how does the system know who I am talking to at any given moment? Do I have to explicitly say, "Hey, Amu," or "Hey, Mycroft" every single time?
You could use different wake words, yes.
Yeah.
But the system is primarily listening for context.
Interesting.
And the technology underneath Amu is fascinating because he actually had to create two completely different versions of her just to handle the speed issues.
Speed issue.
Yes, there's Amu Lite and there is Amu Pro.
Okay, that sounds like a software subscription, like a free version with ads and a paid version.
No, it has nothing to do with payment. It is entirely about balancing latency versus deep intelligence.
Break that down.
Think of it like your own human brain. You have fast, automatic reflexes and you have slow, deep thought.
Right.
Amu Lite is the reflex. It runs completely locally, it is blindingly fast, and it handles simple binary commands like turn the light on.
So it doesn't need to think very hard.
No, it responds instantly in Malayalam script on the local wall screens, but it does not engage in deep, complex reasoning.
Okay, so Amu Lite can flip a physical switch instantly.
Precisely. But what if you ask something highly complex like, Amu, please draft a polite message to the neighbors letting them know their dog has been barking all morning?
That requires actual thought.
The system instantly realizes, okay, the light model cannot handle this level of nuance. So it seamlessly escalates the query to Amu Pro.
And what exactly is Amu Pro running on?
Amu Pro hooks into the Gemini API, and it uses what the research paper calls sociolinguistic pragmatics.
Whoa, okay, slow down there. Sociolinguistic pragmatics? That sounds like a master's degree thesis title. What does that actually mean when we are talking about a smart home assistant?
It means the AI understands the human language is not just a raw exchange of data. It is a complex web of social maneuvering.
Give me an example.
In Malayalam, much like in many Asian languages, strict social hierarchy and respect are fundamentally built into the actual grammar of the language.
Okay.
A direct, blunt command like turn on the light can sound incredibly rude or abrupt, especially if spoken to an elder.
It lacks tact.
Right. A polite request is often phrased much more indirectly, like could you perhaps turn on the light? Or even just an observation like it is getting a bit dark in here, isn't it?
So Amu Pro understands that I am not just asking for a change in lumens in the room. I'm engaging in polite social etiquette.
Yes. She deeply understands the cultural honorifics, the indirectness of the phrasing, and the emotional tone. She can formulate a reply in a way that is culturally appropriate, not just grammatically correct according to a textbook.
That is absolutely wild. It is not just translating words from a dictionary. It is translating social and cultural etiquette in real time.
It is a massive leap forward.
And what about Mycroft? Does he have a Light and Pro version?
Mycroft is described in the documents as the supreme operational intelligence.
Supreme operational intelligence. I love it.
He uses massive GPT-4 class models for very complex system planning and execution. But here's the real kicker for the whole setup.
What's that?
Even though they are using these massive, heavy models for deep thinking, the entire system fights a constant war to keep the time-to-first audio nearly instantaneous.
Ah, right, the latency battle. The research paper seemed completely obsessed with shaving off milliseconds. Why is this such a massive priority?
Because the human brain is incredibly biologically sensitive to conversational lag.
How sensitive are we talking?
In natural human conversation, a pause of more than about 200 to 500 milliseconds starts to feel awkward.
Just a fraction of a second.
If you ask a real person a question and there's a full 1 second pause before they answer, your brain immediately assumes they either didn't hear you or they are deeply confused by what you said.
It completely breaks the illusion of a conversation.
It shatters what they call the magic circle. If I say, turn on the living room lights, and I have to stand there and wait 3 full seconds in the dark, I am acutely aware that I am just shouting at a slow processing computer.
But if it's instant?
If it happens the exact moment the words leave your mouth, you feel like a wizard. Kiran's system is engineered from the ground up to fight for that immediate magical response time.
Let us totally geek out on the actual hardware for a second here. Because he is not running this on a standard off-the-shelf smart speaker, is you?
Not at all. This is heavy metal engineering. The core processing unit he used for the initial prototype is a Lenovo ThinkCentre M910Q Tiny.
Which is a business-grade micro PC.
Exactly. It is a bare metal installation, no bloated operating systems getting in the way. And for the ears of the system, the microphones scattered around the house, he is using these highly specific ATEM M5 satellites.
And how does the processing pipeline actually work? Walk us through the journey of a single voice command.
It is essentially a high-speed digital relay race.
Okay.
You speak a command into the room. The ATEM M5 satellite detects the specific wake word completely locally. There is no cloud involved at this step.
Just hardware listening for its name.
Right. Then, the audio data goes to a speech-to-text processor. Depending on the complexity, this is either Azure's cloud service or a strictly local Whisper model running on the hardware.
Whisper is incredibly accurate.
It is. Once it becomes text, it hits the large language model. Again, either a llama running locally for speed or a cloud model for deep reasoning.
So it thinks about what you said.
Yes. It formulates a text response. Then that text goes to the text-to-speech engine, either Azure Neural or Local Piper, and boom, the audio response comes out of the speakers in the room.
And every single step of that relay race has to happen in under 1 single second.
Well under a second. And the paper actually provides logs tracking the milliseconds of each individual handoff.
That sounds exhausting to optimize.
It is a profound engineering marvel just to coordinate all those system handoffs without dropping the baton or causing a massive bottleneck.
So he builds this prototype in his house. It works beautifully. He has effectively built his Tony Stark mansion in Ayanthiyar, Chitrakoot.
He achieved the dream.
But he doesn't stop there. He looks at this incredible bespoke system and goes, you know who else desperately needs this kind of reliable technology? People who own super yachts.
And that is the fascinating, massive pivot in this story. The transition from an impressive personal research project into a high-end commercial luxury brand. Vœrynth Système.
And we have the commercial pitch deck for this brand.
We do, and honestly, reading through it, it is an absolute masterclass in deeply understanding your target customer.
The tone of the writing shifts completely, doesn't it? It goes from this very academic, here is how I solved a specific linguistic routing problem, to a very bold, here is why your $50 million luxury home is actually garbage.
It is highly aggressive. The pitch deck explicitly states, the current reality of luxury automation is a dumb smart home.
It does not pull punches.
It actively mocks the idea that an ultra-high net worth individual has to stand in their hallway shouting at a cheap plastic puck.
Yeah.
But the core engineering philosophy for the commercial version is built entirely around what they call the iceberg architecture.
I really love this concept. Break down the iceberg architecture for us.
The central idea is that 90% of the system should be invisible. Silent engineering running in the background. They call that the soul of the system.
So the massive servers and the cables.
Right. And only 10% should be the visible interface, the screens and the voice prompts. They call that the skin.
Meaning, as a user, you shouldn't have to be constantly staring at a glowing screen just to run your daily life in your own house.
Exactly. If you want to dim the lights and you have to pull out your phone, unlock it, open a specific smart home app, wait for the interface to load, navigate to the living room tab, and carefully slide a digital dimmer switch down.
That is just exhausting.
That is not a smart home. That is a basic remote control with 10 extra highly annoying steps. That is digital friction.
And it is a remote control that completely stops working the second your internet service provider goes down.
Which brings us to the central unyielding thesis of Vœrynth. Zero cloud by default.
Now, I have to step in and play devil's advocate here for a second.
Go for it.
Why is zero cloud such a massive selling point for the ultra high net worth crowd? I mean, these are billionaires. They have the absolute best, most redundant internet connections money can possibly buy.
They do.
They have dedicated trenched fiber optic lines. They have Starlink dishes bolted to their roofs. Why do they fundamentally care if their light switch connects to an Amazon server?
They care deeply, and it comes down to two very critical reasons: privacy and sovereignty.
Let us start with privacy.
Think about the reality of privacy for these people. If you are a billionaire CEO, or a head of state, or a massive celebrity, and you are sitting in your private living room discussing a hostile corporate takeover, or a highly sensitive divorce settlement, or a major political scandal, do you really want a commercially available Alexa or a Google Home sitting on the coffee table, potentially recording audio snippets of that conversation?
I am going to assume that is a hard no.
We know for an absolute fact that these consumer devices record small snippets of audio for what they call quality assurance and model training.
It is in the terms of service.
We know that vast amounts of consumer data are constantly mined. For average people like you and me, maybe that just means we get weirdly targeted Instagram ads for dog food.
Right.
But for Vœrynth client, that data leak could represent catastrophic corporate espionage or a massive blackmail risk.
The pitch deck refers to this as the privacy void, right?
Yes. Vœrynth explicitly promises that absolutely zero audio and zero video telemetry ever leaves the physical perimeter of the house.
Everything stays inside the walls.
It is a strict air-gapped mentality. The system is incredibly smart, it listens constantly, it sees everything through the cameras, but it physically has no mouth to speak to the outside world. It is a highly intelligent vault.
And what about the sovereignty aspect? What does that mean in this context?
That brings up the deterministic versus probabilistic argument outlined in the technical deck.
Okay, unpack that for me, because deterministic sounds like we are suddenly in a high-level philosophy lecture.
It is engineering philosophy. Probabilistic is how an Alexa operates.
Okay.
You say, turn on the lights. There is a high probability she successfully understands your accent. There's a high probability the cloud server in Virginia is currently online. There is a high probability the return command makes it back to your house.
It usually works.
It usually works, but it fundamentally might not. It relies on probability.
And deterministic.
Deterministic means industrial grade, absolute certainty. It means if I physically press this wall button or speak this specific wake word, the programmed action will definitively happen. Every single time.
Without fail.
The physical laws of electricity determine the outcome, not an unpredictable server load balancer thousands of miles away.
The pitch deck had that absolutely fantastic line. It promised a home that cannot afford drama.
Yes. Imagine the scenario. You are a wealthy client hosting a massive, high-stakes gala at your estate.
Okay.
You have 200 incredibly important guests in your home. Sitting senators, rival CEOs, foreign dignitaries. You discreetly press the evening mode button to elegantly dim the chandeliers and start the ambient background music.
And nothing happens.
Exactly. If the lights do not dim because an Amazon server on the other side of the country is randomly doing a mandatory firmware update, that is drama.
That is deeply embarrassing.
That is massive social and professional embarrassment. Vœrynth is engineered from the ground up to completely eliminate that risk.
But wait a minute, hold on. We just spent all this time talking about the initial prototype using Gemini and OpenAI to be smart.
We did.
Those are massive cloud models. If Vœrynth is now strictly zero cloud by default, how are they actually doing the AI processing? Did they just ditch the deep intelligence to stay offline?
Not at all. They didn't ditch the smarts, they just brought the smarts physically into the home.
Oh.
They pivoted entirely to local intelligence. Instead of putting a $50 Echo Dot in the kitchen, Vœrynth physically installs a massive rack-mounted inference node in your basement. This is a very serious piece of enterprise-grade hardware.
The technical document mentions they are running models with 120 billion parameters entirely locally. Now, I know just enough about computer hardware to be dangerous.
Okay.
To run a neural network model that massive, you usually need a giant server farm. You need a dedicated rack of incredibly expensive NVIDIA H100 graphics cards. How is he possibly running that in a residential basement without the heat melting the foundation of the house?
Yeah, that is a very smart catch, and it is exactly where the software engineering gets incredibly clever. You are absolutely right. You cannot simply run a raw 120 billion parameter model on a standard consumer PC.
It would freeze instantly.
It would run at a speed of maybe 1 word per hour. It would be useless.
Exactly. Turn it off.
Boot off. So the Vœrynth engineers used 2 highly advanced techniques to solve this. First, they use something called quantization.
Quantization?
They mathematically compress the AI model. Instead of using highly precise 16-bit or 32-bit floating point numbers for every single simulated neuron, they aggressively crunch it down to 4-bit precision, or sometimes even less.
Does that make it stupid?
You lose a very, very tiny fraction of overall accuracy, but in exchange, you gain absolutely massive gains in processing speed and thermal efficiency.
Okay, so they shrink the digital brain down.
Yes, and the second vital technique is called a mixture of experts, or MoE.
How does that work?
Imagine the AI is no longer one giant monolithic brain that has to activate entirely for every single thought. Instead, it is a massive room full of highly trained specialists.
Okay, I am picturing a room of experts.
You have a specialist who only knows about physics, a specialist for writing poetry, a specialist for writing Python code, When you ask the system to simply turn on the kitchen lights, you did not need to wake up the poetry guy.
So the whole brain doesn't fire at once.
Exactly. Only the specific, highly relevant part of the neural network fires. This architecture allows them to run a model that possesses the vast knowledge of a massive giant, but operates with the speed and thermal footprint that can actually fit in a standard server rack.
It brings the entire cloud into the basement.
Precisely.
Let us examine the actual technical stack for a moment. The pitch deck compares typical consumer smart homes to spaghetti code.
Which is very accurate.
You know the drill. A Philips Hue bulb has to talk to a Zigbee hub, which has to talk to a Wi-Fi router, which talks to an app. It is a tangled mess. How does Vœrynth organize all this chaos?
They enforce strict discipline by breaking the entire architecture down into 5 distinct layers. It is highly structured.
What is layer 1?
Layer 1 is what they call a hard metal. This is the purely physical stuff, the wires and the switches. And they strictly use industrial commercial standards like KNX and DALI for all the lighting.
I see KNX listed on the spec sheet here. I have definitely heard of it, but how is that fundamentally different from the Philips Hue smart bulbs I can buy at Best Buy?
It is a totally different universe. Philips Hue relies on Zigbee, which is a low-power wireless radio signal floating through the air.
Okay.
If your microwave happens to be running, or your next-door neighbor installs a massively overpowered Wi-Fi router, your smart lights might suddenly flicker, lag, or just completely fail to turn on.
It is convenient, but fragile.
Exactly. KNX, on the other hand, is a physical, hardwired green cable physically running through the drywall of the house. It is an industrial protocol invented way back in the 90s, specifically for massive facilities like airports and sports stadiums.
Wait, airports?
Yeah. Think about Heathrow Terminal 5 in London. Do you honestly think they use wireless Philips Hue bulbs that rely on a spotty Wi-Fi router to keep the terminal lit?
Obviously not.
No. They use hardwired KNX. It is a fully decentralized protocol, meaning if one physical switch violently shorts out and dies, the rest of the entire building continues to function perfectly. It is essentially the cockroach of automation protocols. It simply survives everything.
The cockroach of automation, I really like that description. So layer 1 is entirely bulletproof, hardwired cabling.
Right. Then we move to layer 2, which is where the engineering gets wildly innovative. They call it the translation core. And to build it, they use an open source standard called Signal K.
Now, I looked this up before we started. Signal K is designed for boats. It is an open source marine data standard used in the sailing community. Why on earth is an engineer putting yacht technology into a stationary house?
Because modern boats are incredibly complex, highly varied machines. Think about a massive luxury yacht. It has a massive diesel engine, wind speed sensors on the mast, sonar depth sounders on the hull, GPS arrays, massive battery banks, freshwater tank sensors, blackwater waste tank sensors.
And all that equipment is made by different companies.
Exactly. It is a massive, chaotic mess of proprietary data formats. Signal K was explicitly designed by the marine community to take all those violently different data streams and mathematically translate them into one single, standardized, easy-to-read JSON stream.
Okay, I follow that. But a house isn't a boat.
But Kiran realized a profound truth. A massive luxury home is fundamentally just a big, stationary boat.
That is such a cool lateral insight.
It makes perfect sense. A house has a massive boiler, which is basically the engine. It has weather sensors on the roof to monitor wind. It has complex water tanks, massive electricity usage metrics.
So he uses this marine software as a universal translator for the house.
Exactly. Whether it is an anemometer measuring wind speed on the roof or a massive diesel backup generator in the sub-basement, Signal K ingests all of it and turns it into one unified language the AI can read.
Then layer 3 is the state engine, which the documents reveal is just Home Assistant.
Yes, which is the absolute darling software of the open source smart home community. He openly acknowledges the open source roots of the project here.
What does Home Assistant actually do in this stack?
Think of Home Assistant as the spinal cord of the house. It obsessively tracks the current state of absolutely everything. Is the kitchen light physically on? Is the front door physically open? It doesn't do with a complex, high-level reasoning, but it acts as the absolute source of truth for the status of every single atom in the home.
Which feeds into layer 4, the brain. That is the highly proprietary Vœrynth core that actually does the deep reasoning.
Right. That is where the locally hosted 120 billion parameter MOE model lives and breathes.
And finally, we arrive at layer 5, the skin. The visual neural interface, this is what they call Vœrynth OS, And we actually have the internal GitHub README file for the software, which gives us an amazing peek right behind the curtain.
It is stunning.
Yeah.
And they're very clear that this isn't just a web dashboard. The README explicitly calls it a command deck.
The tech stack looks incredibly modern. React, Vite, Tailwind, CSS, WebSockets.
But again, the absolute primary obsession running through the code is zero latency.
They extensively outline this predictive SPA concept on the website source code too. They call it SmartLink. This completely blew my mind when I read it. Please explain what SmartLink actually does.
It is basically a digital magic trick designed to make the system feel like it operates faster than the speed of light.
How?
Normally, when you are using an app, you click a digital button, your browser sends a network request to a server, the server takes a moment to think, and then it sends the next visual page back to your screen. That whole round trip takes maybe 200 milliseconds.
Which is objectively fast, but still noticeable to the human eye.
Vœrynth uses highly aggressive intent detection.
Yeah.
When you hover your physical mouse, or even just move your finger in the general direction of a button on the glass panel,
The system is watching that movement.
the system mathematically predicts that you are highly likely to click that specific button. It secretly starts rendering and loading the next visual page in the background before your finger actually makes physical contact with the glass.
So by the time the electrical impulse actually travels from your brain down your arm to your finger to complete the tap,
The next page is entirely rendered and waiting for you. It feels mathematically instant. It feels like the system genuinely knew what you wanted to do before you did it.
that is exactly that magical Tony Stark feeling. It is not just functioning fast, it is actively anticipatory.
And for the core application itself, the code shows they use service workers to aggressively cache absolutely everything locally. This provides what they call offline sovereignty.
Meaning,
If the external internet connection suddenly dies, the app does not instantly crash to a blank white screen with a little pixelated dinosaur. It stays 100% fully functional, looking beautiful, because the entire application lives physically on the device in your wall, not on a server in California.
speaking of looking beautiful, the visual design is described in the deck as couture grade. Dark mode, absolutely no clutter. It literally looks like the bridge of a futuristic spaceship.
And crucially, Vœrynth strongly prefers installing physical wall panels. Hardwired power over Ethernet touch panels embedded seamlessly into the architecture.
Why not just use iPads?
Because ultra-wealthy individuals do not want to hunt around their living room for a misplaced, uncharged iPad wedged under a sofa cushion just to turn off the overhead lights. The primary control should be a permanent, deeply integrated part of the architecture, functioning exactly like a traditional, reliable light switch.
Okay, we have talked extensively about the houses. Now I really want to shift gears and talk about the boats.
The super yachts.
Yes, because Vœrynth offers a specific super yacht edition, and the commercial pitch deck actually gets genuinely funny here. It refers to the cloud as a fair weather friend.
It is a brilliant line because it is a literal and a figurative truth. When you are physically on a massive superyacht crossing the open Atlantic Ocean, you obviously do not have a trench with a fiber optic cable physically plugged into the wall.
Obviously not.
Your entire internet connection is coming via massive VSAT domes or maybe an array of Starlink dishes.
Which is undeniably amazing technology, but
But it is inherently spotty. It is astronomically expensive. And in a heavy storm at sea, the physical signal attenuation from the heavy rain, which is called rain fade, can completely kill your satellite connection.
so if your multi-million-dollar yacht is somehow running on Alexa and the satellite connection drops during a storm,
You literally cannot turn on the lights in the master cabin. You cannot ask the system to check the engine diagnostic stats. You are effectively technologically blind in the middle of the ocean.
that does not just sound inconvenient, that sounds actively dangerous.
It is highly dangerous. That is precisely why the hostile marine environment is the absolute ultimate proving ground for this local first engineering philosophy. If the satellite internet completely dies on a Vœrynth-equipped yacht, the only thing the owner actually loses is the ability to stream Netflix. The ship itself continues to think and function perfectly.
The documents explain that Vœrynth tightly integrates with NMEA 2000. For the landlubbers out there listening, what exactly is an NMEA 2000 network?
It is basically the central nervous system of any modern marine vessel. It is a highly robust physical cabling standard that connects all the critical hardware. The GPS array, the sonar depth sounder, the radar dome, the massive diesel engines, the wind instruments on the mast.
It carries all the life or death data.
Exactly. Vœrynth plugs directly into that physical nervous system. The AI essentially becomes the digital second officer of the vessel.
Give me a concrete scenario of how that works. The pitch deck had a highly specific example about anchor drift that honestly terrified me a little bit when I read it.
Right. So picture this scenario vividly. It is 3 o'clock in the morning. Your massive yacht is anchored just off a rocky coast in Ibiza.
Okay, setting the scene.
The incredibly wealthy owner is dead asleep in the master suite. The professional crew is fully asleep down in the hull. Suddenly, the wind silently shifts and picks up. The massive anchor loses its grip and starts dragging slowly along the seabed. The boat is now drifting directly toward a jagged reef.
In a standard traditional boat, what actually happens in that exact moment?
A tiny, high-pitched electronic beeper starts going off on the navigation console up on the bridge. But absolutely nobody is standing on the bridge. It is 3 a.m.
So the beeper is just uselessly beeping into the empty void while the boat slowly crashes into the rocks.
Precisely. Unless a crew member happens to naturally wake up and physically hears that tiny beep through 3 solid decks of steel and acoustic insulation, the vessel is in catastrophic trouble.
But with Vœrynth acting as the second officer...
Vœrynth is silently, continuously reading the live GPS coordinates and the depth sounder data via that NMEA 2000 network. It mathematically detects the uncommanded movement. It rapidly calculates the drift vector and the time until impact.
It understands the physical danger.
It does not just beep. It immediately initiates a complex, multi-stage, critical alert protocol.
Which involves what exactly? Walk me through the protocol.
First, it wakes the physical crew down in the hull, gently but very firmly. It slowly pulses the overhead lights in the crew cabins, but strictly in the color red.
Why specifically red lights?
Because red light scientifically preserves human night vision. If you wake a sleeping sailor up by blasting them with bright white LED light, they are physically blinded for several minutes.
That is incredibly smart. That is highly tactical.
Red light allows the crew to wake up, instantly run up the dark stairs to the bridge, and immediately be able to clearly read the glowing instrument panels and look out at the dark ocean.
Every second counts.
Then, the localized voice panels in the crew quarters clearly announce, "Anchor drift detected. Please report to the bridge immediately." Simultaneously, it sends a highly specific, silent readout of the situation directly to the captain's bedside panel. It does not panic. It actively manages the crisis.
That right there is the fundamental difference between a cool tech gadget and a true life-saving system. One just beeps mindlessly, the other actively manages the physical reality of the situation.
And does all of this completely autonomously while operating in what they call island mode.
I love that term, island mode.
It simply means the AI system is entirely self-sufficient. It is also actively balancing the massive energy loads of the boat locally.
How so?
If the primary diesel generator is suddenly overloaded during the emergency, Vœrynth is smart enough to instantly shut down non-essential luxury systems. It will cut power to the jacuzzi heater or the empty guest room air conditioning, specifically to ensure the critical navigation computers and the physical stabilizers have enough power to keep running. It actively thinks about the vessel's survival.
Now, we need to talk about the money, because absolutely none of what you just described sounds remotely cheap. I am guessing you do not just pick up a Vœrynth box at Walmart.
Absolutely not. And looking closely at the business model section of the pitch deck, they are incredibly defiantly proud of that fact. They explicitly make fun of the modern software as a service model.
The dreaded SaaS model.
You know the drill. Pay $10 a month for the rest of your life or your video doorbell magically stops working.
Which is the absolute bane of modern consumer existence. I literally own a smart electric toothbrush that constantly begs me for a monthly subscription via Bluetooth. It is madness.
Exactly. Vœrynth violently rejects that model. They operate financially like a high-end architect or bespoke tailor. You do not pay a monthly subscription for the structural walls of your house. You pay a massive sum up front for them to be meticulously designed and physically built.
So how does their actual pricing structure work?
It starts with a massive design fee. Just to sit down and mathematically plan the logic of the system, you are looking at writing a check for anywhere between 15,000 to 40,000 euros.
Whoa, 40,000 euros. That is the price of a luxury sedan, just to draw up the digital blueprint.
Just for the bespoke logic, just for the incredibly complex wiring schematics and the personalized AI programming. Then, crucially, the client buys the actual hardware, what they call the bill of materials, directly.
So Vœrynth doesn't supply the servers?
They will supply it, but they explicitly do not mark up the hardware costs, which is a very interesting business choice. They want the client to legally, physically own the silicon hardware outright.
So you buy your own massive servers, you buy your own custom glass wall panels, and then what happens?
And then comes the commission. This is my absolute favorite philosophical part of the company. You do not just download or install a Vœrynth system. You officially have it commissioned.
Like an oil painting or a massive naval vessel.
Exactly, because every single build is a totally unique, unrepeatable piece of engineering.
And this ties all the way back to the persona concept we talked about earlier, right? You don't just get a generic Siri voice. You actually get to choose your AI's core personality.
Yes, you architect the soul of the house. The pitch deck specifically mentions that a client can choose a persona, like Aurelius the ship captain or Alfred the butler. You purposefully choose the personality that perfectly fits the vibe of your daily life.
Wait, hold on. Can I really choose a literal ship captain personality for my house?
You absolutely can. If you want a grumpy, highly authoritative nautical ship captain running the daily logistics of your estate, you can have them program that exact persona.
I would absolutely pay extra money for a grumpy ship captain AI. I just imagine saying, turn on the TV, and him responding with, permission denied, the barometric pressure is falling rapidly, batten down the hatches instead.
Read a book, sailor. Exactly. It turns cold software into a completely bespoke suit. It is mathematically tailored to fit your specific life, your daily routine, your bizarre personal quirks.
So we have explored this incredible technology. We have outlined the strict offline philosophy. We have dissected the bespoke business model. But I really want to circle back to the actual man behind all of this, Kiran Achari. The thing that strikes me the most is the wild blend of different disciplines here.
It is exceptionally rare to see. You have the strict, unforgiving rigor of German engineering, specifically that Bohm system engineering background,
Right.
combined with the deep human cultural necessity of solving the bilingual code-switching problem for his own family. And on top of that, you have the sheer audacity to look at the biggest tech conglomerates in the world and say no.
He looked at Amazon and Google and essentially said, your entire foundational approach is wrong for this specific group of people.
He correctly identified that the word smart does not automatically mean internet connected. That is the key, profound insight of this whole system. As a society, we have dangerously conflated those two concepts. We honestly think that if a kitchen toaster is not actively pinging a Wi-Fi router, it is dumb.
Because that is what we were sold.
Right. Kiran is aggressively saying no. If the toaster fundamentally depends on a fragile Wi-Fi connection just to make toast, that is what is truly dumb.
Invisible intelligence. That is the exact phrase they use throughout the marketing. The absolute best smart home is the one you do not have to constantly give verbal commands to.
It mathematically anticipates your needs. It knows it is a Friday night. It sees via local sensors that you are home. It checks the local weather data and sees it is freezing outside. So it proactively adjusts the ambient lighting and cranks the heat before you even realize you are cold.
That is true luxury.
Luxury is the complete and utter absence of daily friction.
And I would argue the complete absence of fear. The low-level fear that your private voice data is constantly being recorded and sold to advertisers. The fear that the Amazon server will magically go down right when you need it.
Precisely. Total local control.
So what does this all practically mean for the rest of us? The average people who maybe cannot afford to write a 40,000 euro check just for a design fee. Is this entirely just a shiny, bespoke toy for global oligarchs, or does this actually matter for the rest of us?
I think it vividly points to a very fascinating and honestly somewhat terrifying future. We are rapidly moving toward a massive digital class divide.
Elaborate on that. How so?
Think about the economics of it. The poor, and by poor I just mean the general mass consumer class, you and me, will continue to have devices that are incredibly cheap up front. The Amazon Echo Dot goes on sale for $30.
Because the hardware is subsidized.
Exactly. But the real hidden cost is our constant stream of personal data. We are the actual product. Every sound in our home is being quietly listened to, processed, analyzed, and eventually sold to the highest bidder.
We pay for the cheap hardware with our personal privacy.
Exactly. And the rich.
Right.
The ultra-wealthy will pay astronomical sums for absolute digital silence. They will pay a massive premium for powerful hardware that explicitly does not talk to the outside internet. They will completely own their own digital infrastructure. True, air-gapped privacy and absolute offline capability are rapidly becoming the ultimate status symbols of the 21st century.
That is a remarkably heavy thought to process. The ultimate modern luxury isn't actually having the newest, flashiest connected gadget. It is having the immense financial power to completely disconnect from the cloud and still have your entire environment seamlessly work for you.
Exactly. While everyone else is hopelessly tethered to the cloud, constantly refreshing their apps, just praying the Wi-Fi connection holds up during a storm.
However, there has to be a silver lining here for the rest of us, right? Technologies like these, highly compressed local LLMs, extreme quantization, lightning-fast offline voice recognition, they fundamentally get cheaper and easier to produce every single year. Vœrynth is essentially the absolute bleeding-edge Formula One race car of the smart home world. It is insanely expensive and completely custom right now.
But the technology always inevitably trickles down. Eventually, your boring Toyota Camry gets the exact same electronic paddle shifters that were originally invented for a multi-million-dollar F1 car.
So there is hope.
Hopefully, in maybe 5 or 10 years, we can all have a highly intelligent, purely local AMU running quietly on our own cheap hardware, keeping our family's data completely safe from big tech.
Let us sincerely hope so, because I really, really want that grumpy ship captain AI running my apartment.
I think we all do at this point.
Well, on that exact note, the very next time Siri cheerfully tells you she didn't quite catch that, or your kitchen Alexa randomly starts listing off ingredients for a complicated recipe you definitely didn't ask for.
Just take a deep breath and remember, somewhere out there in the dark Mediterranean Sea, on a completely silent superyacht, a localized AI just successfully ordered the owner a perfectly chilled martini.
And it managed to do it without sending a single solitary packet of data back to a server farm in Silicon Valley.
Cheers to that absolute engineering triumph.
Stay curious, everyone. And maybe one day, stay offline.
Indeed.